All right, second hour, we're live. All right. Okay, so what this I said I was going to do. Boom, boom. Just remember the forms that we have so far. Y equals A x minus h squared plus k. That's vertex form. Okay, remember that? Right? And then we have that little added that's not really in the book. A x minus, and then they just use p and q as some letters. Again, it's just variables. We could choose anything we want, but most books, when they put it in what's called intercept form, they do use the p and the q, and in all math books kind of use the same situation there. That's when you have the x-intercepts. And understand that those give different information when you're graphing parabolas. Most books start off with this form. So this was a little difference for us math teachers, and it's fine. This form is called standard form. All right. And this is the form that you saw. I could use f of x or y. Hopefully you understand at this point, f of x is the same as y, just function notation. This is the form that you saw with factoring. When we first started factoring polynomials, they were in this, and we did use the term standard form. We used the term standard form where the highest degree was written first, then the next degree, and then the constant. And then we factored like polynomials like that through that complicated MA method. Well, now we're graphing. So there's something that this gives away as far as graphing is concerned, but we're going to have a formula for that we understand. Does anyone know what time we get out of here? Sorry, I forgot to check that, and I'm tethered to this thing. Anyone know what time this class ends? Oh, no, I got to leave. I got it. 9:13, right? Okay, so let's just make sure we remember that. I'm back. 9:13. Sorry, just had to make sure we have a good time here. Okay, so this is all review. Y equals or f of x equals, that's the parent function. So obviously that's the one where we have graph down here who has a vertex of 0, 0. And by the way, input, say it. Come on, second hour. Input, output, only a couple. Be ready like ninjas to answer those questions. See, graphing is I plug in 0 for x, square it, and I get 0 for y. 0, 0 is now a point. I know some people are like, come on, stop doing this. I don't care. I teach CAT classes with seniors, and we do a ton of graphing. And we do a lot of input, output. Actually, every graph that we do, we start with input, output. So they understand that this is what a picture is, and this is why the picture is what it is for whatever function we're dealing with. 1, input that. 1 squared is 1 for y. 2 squared is 4 for y. -1 squared, -2 squared. All right, there you go. That's why we get a parabola for x squareds, because the parent looks like that. So what I call the other ones are children, the children of the x squared family. They all look like that, but then changes are made, shifts and moves and different vertexes and all that other stuff. So again, a reiteration, the axis of symmetry is a line that cuts the graph in half. X equals, you will always write the axis of symmetry as x equals a number, because that's the equation of a vertical line. Didn't get a chance to teach you lines. Hopefully you did that through last year. And passes through the vertex. I have like a hair on my face as you see me trying to grab this. I think I see it. All right, there we go. All right, this is not new, but what I want you to understand is look at this. 3 forms. Sorry, supposed to be the highlight. A, and A. Now this is what we're gonna work on tomorrow when we do our online thing on Wednesday. Yes, you could have the same picture, and we could write that picture, that parabola, in 3 different forms. And those 3 different forms give different information. The A value would be equal in all 3 different forms. Okay, so again, I'm talking about the same graph that I could put in 3 different forms. The A would be equal. So it's the same idea. If A is greater than 0, that means positive, then it would go up. If A is less than 0, then the parabola would go down. That's true for all three forms, okay? So make sure we understand that. And as I move on, if A is greater than 1, here's the better math word. There's a stretch vertically. And actually, I'm going to write that down because we're in CAT class with seniors and certainly in Math 3 honors. There's also stretches and shrinks horizontally, which is a little different. We're not going to do that. We'll wait for Math 3 honors, or if you go through the CAT thing as a senior, we'll do that in CAT. We're just going to stretch and shrink vertically. All right. And then if A is less than 1, that means a fraction, 1/2, 1/3, 1/4 x squared. Then you're wider, but really what we should say is a shrink. This is not new. This is true when we went through all of this with the other two forms. So I felt it would be okay to reiterate it. And now let's get into the specifics of when you're in quadratic form. I'm sorry, when you're in standard form. Okay, so I'm going to highlight this. The next 3 boxes are 100% what you need to know for standard form. So I'm going to color this and highlight this. This is specific to this form. Okay, now I say this all the time, and it's not being rude. It's the truth. Sometimes you learn something, and it's just like a definition, and you just got to lock it in. And then there is no I don't get it. You just don't know the definition. With math, it's mostly formulas, and you have to memorize formulas. There is no I don't get it. There is I just don't have the formula memorized. Because for when you are in standard form, you have to memorize this. We're going to start by finding the axis of symmetry. Now, I asked period 2 and period 3 yesterday, did anyone know or anyone hear of the quadratic formula? Raise your hand if you've ever done a quadratic formula. Dang. Okay, you did maybe? Heard of it? No, it's not this, but it just quadratic formulas does something that's not related to this. You ever hear of it though? Just asking a question. Okay, good. So a few. One person in my second hour, none in third hour. What I'm going to write next is actually a part of the quadratic formula, and there is a relationship. And we're going to do quadratic formula in period 4. It is this formula, x equals negative b over 2a. That is a formula. That is something you need to remember. When I'm in standard form, I'm going to start by finding the axis of symmetry, which is x equals, vertical line, and then this magic formula, negative b over 2a. Some might ask, where are you coming from with this b and 2a? It's right here. Here is b. It is the coefficient in front of the x. Here is a. It is the coefficient in front of the x squared. Now, if anyone knows the quadratic formula, you remember the opposite of b, plus or minus, the square root of. Anyone? Is this what you remember as the quadratic formula? Raise your hand. B squared minus 4ac all over 2a. The first part of the numerator is negative b. The bottom is 2a. There's a relationship between this and the quadratic formula. If you don't know the quadratic formula, don't feel bad about it. It is supposed to be a new concept for us this year. All right, but I just like to know who knows what as we go through this. Okay, and then finding a y-intercept. This is true always. Yesterday I asked all my classes, did you know how do you find a y-intercept for anything? And the answer for that is the y-intercept always, I don't care where it's at, has 0 for x and then some number for y. That is the only way you could be on a y-axis. Hence, a y-intercept will always be 0, comma. Now let's go ahead and look at this equation and see what's valuable about standard form. Look at what happens. I can't go to the screen and point. By the way, I should stay here anyway. What happens when I plug in, I guess I can't change that, 0 here and 0 here. What is the only thing that's left over? I heard it. C. So the y-intercept is 0, comma, C. So standard form actually gives you the y-intercept immediately. Okay, you can see it by, if I plugged in 0 for x, I'd be left over with whatever c is. And by the way, c is going to be a number. This is just like a formula kind of situation. All right, and then the last thing is, what is the vertex? Well, the vertex, the axis of symmetry, no matter where it's at, let's say we have a parabola doing this, the axis of symmetry goes through the vertex, and more importantly, it goes through the x value of the vertex. So the negative b over 2a also finds the x value of the vertex. What do you do with that x value to find the full vertex? This is input, output notation. F of negative b over 2a means plug in negative b over 2a for x, solve for y. That's all that means, f of negative b over 2a. So negative b over 2a gets the ball rolling. It's the absolute positive most important thing in standard form, what you have to remember. That's why you need to lock it in. There is no I don't get it. There is memorization, right? And that's what we need to do. Okay? Thought I heard my door move. Uh-oh, fumble. The new pencil? Oh, all right. All right, now, this isn't bad. Remember what minimum and maximums are called. This is your math 3 teacher will be really mad if you don't know the word extrema. Extrema are maximums and minimums, okay? It's a general big fancy math term, just to be honest. And then remember the maximum or minimum is the y coordinate of the vertex because you're describing the high or low y value. There's a minimum when a is greater than 0. All we're saying is when the parabola goes up, there's a low point. There is a minimum. When a is less than 0, there's a maximum because that sucker's going down. So therefore, you have a high point for a y value. So again, that's not new. That's the same for all the forms. So I do like these. These are old Algebra 2 notes, but parabolas don't change. So you don't care about that. I know we're in math 2. Just remember, the middle part is specific to quadratics, and negative b over 2a is the big, big, big idea. All right? Pause and let people in class have a chance to write. Standard lecture, I won't bother you today. But have any questions, feel free to fire away. Until 9:13, we should be good. Move that over there. Okay, good. All right. Good to go. Can I move on? Thumbs up all the way across. Fumble again. All right. All right. And then this is the pattern that we're going to follow. Actually, I should put this a little bit more in there. We're actually going to find the axis of symmetry and then the vertex, because now we found out they're related. Since the axis of symmetry goes through the vertex, it also gives us the x coordinate of the vertex. So one is really 2 steps. Find negative b over 2a, and then find the vertex, and then find the axis of symmetry in the vertex. I'm going to say make a 5-point table. I've been okay with 3 points sometimes, but I think 5 is not bad if we do what I show you here. All right, so we are going to find 4 other points, and we're going to do that the way I show you how we do that. Then graph the points and then make a parabola, nice and smooth curve. All right, let's give you a minute to label that. And then there's our first example with a little table to the left. And notice I'm cut off a little bit on the screen, so move this a little bit that way. It's not that bad. Okay, so even at home, if we're not here, this little time in between is pretty good for seeing what you missed. Shouldn't need too much time. Yesterday, I had 3 examples ready. I only did 2 of them because I think it really hammered the point down, so it was okay. Hey, as you're writing, everybody, just to get this moving along, what's A? Can I hear out loud? 3, 2, 1, go. Oh no. What's the A value for this particular equation? 3, 2, 1, go. Nice. We do have a second hour. Oh no, this one may cause stress. In 3 seconds on the countdown, what's B? 3, 2, 1, group response. Nice. Okay, 0. We don't have a middle term, so B is actually 0. Then, of course, what's C? 3, 2, 1, 2. Now, I know that's the, if those are ahead of the game, they already know what the Y-intercept is. Let's go ahead and find the vertex and then find out what the vertex actually really is. So I'm going to move up here. And don't worry about writing all this stuff down. You can shorthand this. We'll fill this all out later. I'm just going to graph. So really, let's focus on the charts, not on A through F. You don't have to write all this out specifically. And for equation of axis of symmetry, just put A of S, or something like that. Really learn how to shorthand your notes. Okay, but for the axis of symmetry, I'm going to put this work up here. X equals negative B over 2A. In 3 seconds, what's 0 over 2 times negative 2? 3, 2, 1. One person, 2, 0. You're right. So the axis of symmetry is 0. That's because 0, when plugged in, the Y-intercept is actually the vertex. Okay, so if you're thinking the Y-intercept is 0, 2 already, well, it also is the vertex because it is. And then if you equate this to the vertex form, this could be considered to be in vertex form as well. I don't want to confuse you, but really, if I put that around there, 0 is the x coordinate of the vertex, 2 is the y coordinate of the vertex. So that's how sometimes these kind of coincide with each other depending on how much information you got in this little scenario. But don't let that confuse you. Let's just move on. And then what you do is this. You go one above and one below that x coordinate. If that truly is the vertex, then these two x coordinates should have the same y coordinate. That is how parabolas work, the symmetry aspect, reflected across the axis of symmetry. So I take one and I plug it in. I hate to have to write this, but I will. You should mentally do this. You should never have to write this, I hope. I hope you understand that when I plug in 1, I get 1 squared, 1 times negative 2, which is negative 2. Negative 2 plus 2, is 0. Let's check if you get that with negative 1. And then if you do, you have the vertex. You have a reflected image here. Negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. By the way, what are those two coordinates called? 1 comma 0 and negative 1 comma 0. 3, 2, 1, go. Oh no. What is 1, 0 and negative 1, 0 called? 3, 2, 1. Oh no. What is it crossing? What axis is it crossing? What axis is it on? Those are x-intercepts. Okay, by accident, we found the x-intercepts by randomly plugging in a point or two. So interesting. And then I'm going to go 2 and negative 2, and this is what I'm going to do. I'm only going to plug in one of them because now I should see that this parabola has that parabolic thing going on where I have points reflected across the axis of symmetry. So I plug in 2. Fine. As a note teacher, I'll do it. I really think this is something you should do mentally, though. I don't need to see this for work. Okay, do understand that. But 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 2 is negative 6. And you know what? I know that should be negative 6 as well because I already see this symmetry going on. So I'm going to zoom back a little bit, and then we'll fill in those boxes. 2 comma 1, 2, 3, 4, 5, 6. And by the way, that's my reflection sound. By the way, then I fill out these boxes later. Don't write out this whole thing. The vertex we already found is 0, 2. we should have known it was opening down before we started. So make sure your points make sense, that it does go down with the coordinates that I plug in. Otherwise, you made a mistake. We do say that it is stretched, and we do say by a factor of 2. That 2 is what made that stretch compared to the parent. All right. There is a maximum. I almost circled the wrong thing there. So just say there's a max at. Don't write this whole thing out. There's a max at 2. That's what we say. We say it's the y coordinate of the situation. Okay. So that's basically how you break this down. Nothing really special happened with this one because I didn't have an x value. So that's the point of my next example. But we'll leave that up there for a second. Zoom out a little bit so we can see. Then those jumping ahead, go ahead and write example 2. And I think that's, well, and I'll show example 4. That was just one where they try to compare some the forms. Okay, good to go? Thumbs up? Okay. All right. And then just for purposes of time, I won't bother you with some questions. But hopefully the ball's rolling and you understand what we do first. I know it says letter D, but this really gets the ball starting. The opposite of B, and this is what I do on a test. I just go, all right, A, B, C. I remember as a kid doing this. I remember saying, okay, A, B, C. A is the x squared number, B, and then C. The opposite of B over 2A. And that is -6/6, which is -1. So the axis of symmetry is -1. I go right to my chart right in the middle and I put -1, knowing that should be the vertex x value. Very specific to this form. Then I take -1 and I plug it in. I'm crashing into my question here. Oh, I put plus, but now it's plus a negative. Okay, and then be careful. -1 squared is 1. 1 times 3 is 3. Hold 3 in your head. -6 minus 2. All right, so 3 minus 6 is -3. Minus 2 is -5. Shouldn't really have to teach that. You're just plugging in, know how to evaluate. Then the next thing, you go 1 away. That's 0 and -2 on either side of -1, -5. Because what I'm trying to show is -1, 1, 2, 3, 4, -5. From this point out, that's the vertex, and there should be that symmetry thing. So that's why I'm plugging in those two. Hey, by the way, 0, 0, anyone? 0, anyone? Look at what 0, gives us. 0, is always the what? Oh no! That's one of those. Anyone get those phone calls that are not anybody? Yep, one of those dumb phone calls. What's 0, The Y-intercept. What's going on, guys? Okay, 0, -2. When I plug in 0, these get destroyed. I end up with -2 as the output value. All right, and then I might check -2 just to make sure. Hey, what if you got the wrong vertex? If you got the wrong vertex, then you will not get -2 here. You will not see that symmetry going on here. -2 squared is 4. 4 times 3 is 12. Hold 12. Ah, this is nice. 6 times -2 is -12. 12 plus -12 is 0 minus 2. Yes. So this proves and verifies I found the right vertex, 0, -2, and then -2, -2. Proves that symmetry, proves that we have a parabola going up, which I should have asked to begin with. Which way is this parabola going? And then one more point. 1, because that's 1 away this way, and -3. And at this point, I'm so confident, I'll plug in 1, I won't plug in -3. I'll assume I know what I'm doing here. I got my vertex. I'll know this symmetry is going on. 1 squared is 1. 1 times 3 is 3. 3 plus 6 is 9. 9 minus 2 is 7. So I'm going to be pretty sure that that should be 7 as well, because symmetrically what I've done here. 1 comma 7. Ooh, boy, this is a real skinny one. -3 comma 7. All right, and that's because we have that 3 as an A value. Nice and smooth curve. We already had the vertex, so that's just a reiteration. It opens up. We should have analyzed that to begin with. It is stretched by a factor of 3. Got that, and then that means we have a minimum at -5. Had to look at that real quick. So you have a minimum at -5. All right, and we won't have time for that example 3. What time did we get out of here? 1 minute. Okay. I was going to show this one thing about path of a ball, so on and so forth. Maybe I'll show that little thing as one little video for third hour. So again, very specific to standard form. Most important thing you get out of here and memorize is what I have highlighted in yellow there. -b over 2a gets the ball rolling.